So we'll practice recently asked questions in JEE, and from there we'll get an idea about the questions which are coming in inverse trigonometric functions. And then you will do few assignments on inverse trigonometric functions after the class that will be sent to you. It will be around 30 questions. So let us start in 1 minute. Okay, so let us start now. I think everyone who has to join has joined till now. So the first question which we will be discussing today is, if cos inverse 2 by 3x plus cos inverse 3 by 4x is equal to pi by 2, and it is given that x is greater than 3 by 4, then x is equal to, options are given, square root of 145 upon 12 and square root of 145 upon 10 and square root of 146 upon 12 and square root of 145 upon 11. This is 46. So if we approach this question, what we have to think here first is that this equation cos inverse 2 by 3x plus cos inverse 3 by 4x is pi by 2. And we know that there is a property, that property is very important, and I should write all those properties here which are related to this one property. Sine inverse x plus cos inverse x is equal to pi by 2. This is one property. Sec inverse x plus cosec inverse x is equal to pi by 2. This is another property of the same category. Tan inverse x plus cot inverse x is equal to pi by 2. So we have to take the help of one of these three properties and we can proceed. So first write this question and then this property, then we will discuss how to approach. Okay. So if we proceed now, it is cos inverse 2 by 3x plus cos inverse 3 by 4x. So cos inverse 2 by 3x plus cos inverse 3 by 4x is equal to pi by 2. Now you can write it as cos inverse 2 by 3x is equal to pi by 2 minus cos inverse 3 by 4x. You can write it like this. And then this is equal to, we know here that sine inverse x plus cos inverse x is equal to pi by 2. This is the property. So we can write pi by 2 minus cos inverse 3 by 4x as sine inverse 3 by 4x. 90 minus cos inverse 3 by 4x is sine inverse 3 by 4x. So we have used this property number 1. And then we can say that this cos inverse 2 by 3x is equal to sine inverse 3 by 4x. Now we have to proceed further. So if we want to proceed further, there is a standard way in which we proceed in such situation, that what we do, we can take any one. Either we can take the left hand side or we can take the right hand side. Anyone we can take. So if we take any one of them and suppose that they are theta, that is, let us say that since these are the angle now, because cos inverse, there is some value inside it, it will give an angle. Sine inverse, some value inside it, it will give an angle. So that angle, both of these angle are equal. So we can say, let us suppose they are theta. Let us say like that. So this is theta. Now when you proceed that this is theta, so what you can write it as 2 by 3x is equal to cos theta. This is what we can say, that this is cos inverse 2 by 3x is equal to theta, means 2 by 3x is equal to cos theta. And sine inverse 3 by 4x is equal to theta, means 3 by 4x is equal to sine theta. So this is what we can say. Now how we proceed further here, what we do here is, this is what we have done till now. No? Yeah. So now what we will do, we can use this property that we have cos square theta plus sine square theta is equal to 1. So if we proceed like that, cos square theta plus sine square theta is equal to 1. So it is 2 by 3x whole square plus 3 by 4x whole square is equal to 1. So this will become 4 by 9x square plus 9 by 16x square is equal to 1. This is what is going to be. And then let us find the LCM, then it would be, okay, so LCM would be 9 into 16, that will be 144. So it will be 144x square, and 64 it will be here, plus 81 it will be here is equal to 1. So it will be 145 is equal to 144 x square. So we get x square as 145 by 144. So x is equal to plus minus root over 145 by 12. Now, since we know that it is given that x is greater than 3 by 4, so if x is greater than 3 by 4, we won't take minus value, we will take plus value. So therefore, x is equal to root over 145 by 12. This will be our answer. And now let us see which option is this. So this is option A. Okay, so just write it down. So we take positive value, right? Now, based on the graph, because there are many graphs of inverse trigonometry, depending upon the type of function which we choose. So basically, if we consider the graphs of the trigonometric functions like cos inverse cos x, sine inverse sine x and all. So I'm just telling you those graphs, then we'll do a question on that. So sine inverse sine x graph. If you plot this graph, you get something which is like this. So this is sine inverse sine x graph. Let us mark the points. This is 0. This is pi by 2. This is also pi by 2. So sine inverse of sine pi by 2 is pi by 2. Similarly, this is minus pi by 2. And this is also minus pi by 2. And then this is pi. Then this is 3 pi by 2. And then we have 2 pi. Then 5 pi by 2. Then 3 pi. And here also minus pi. And it goes on like this till from minus infinity to plus infinity. So if we see this, what we observe here is that this is the graph of sine inverse sine x, and the domain is real number, whereas the range is minus pi by 2 to pi by 2. The values will always between minus pi by 2 to pi by 2. So this graph we need to know. One more graph which we need to know for the upcoming question is the graph of cos inverse cos x. So because it is not possible to tell all the theory in one question, in one class, and it is type of a revision class, it is a crash course. So we will keep on doing questions, and whatever theory is being used in those questions, we'll do those theories, a revision of those theories. So this way, theory will be used in the upcoming question. So that's why telling you this. So this is a graph which may be something like this. Like this. And the values here are pi by 2. This is not pi by 2. This is pi. And this is also pi. So cos inverse cos pi is pi. Then this is 2 pi. This is 3 pi. This is 4 pi, so on. This is minus pi, minus 2 pi, so on. So the domain of cos inverse cos x is also real number from minus infinity to plus infinity, whereas the range is 0 to pi. The output which we will get is 0 to pi, because the principal value of cos inverse x is 0 to pi, whereas principal value of sine inverse x is minus pi by 2 to pi by 2. Now, if we come to the question says that if, one second, if x is equal to sine inverse sine 10 and y is equal to cos inverse cos 10, then y minus x is equal to, options are given here, 0, 10, 7 pi, pi. So first write these graphs, note on them, and then try this question based on this graph. So what you have to remember here is these two graphs. And then if you plot the value 10 in them, so pi value you all know. Pi is 3.14 approximately. So where 10 should be? So if you see this sine inverse sine x, 3 pi is 3 into 3.14. That is approximately, you can say that it is 9.42 approximately. And the next value, which will be 3 pi plus pi by 2, because this increase of pi by 2 is there, that we can see. So it will be approximately 9.42 plus pi by 2, that is 1.57. So it will be greater than 10, obviously. So what we observe here is that 10 is somewhere here. 10 is here. So this branch is actually having some equation, and here 10 lies. So what is the equation of this branch? So again, by transformation of graphs, that we have to know, transformation of graphs. This line is y is equal to x, and this line is y is equal to minus x plus pi, because minus x will be a line which will be like this. This will be minus x. This is y is equal to minus x. So it is shifted by pi units to the right. So we will say that it is minus x plus pi, right? So this is fine. Now this is y is equal to x minus 2 pi, because this line is y is equal to x. So if it is shifted to 2 pi units from 0 to 2 pi, it will be y is equal to x minus 2 pi. Now this line is y equal to minus x plus pi. Then this line which is shifted here, this red line will be again 2 pi units, it is getting shifted. So y is equal to minus x plus 3 pi it will be. So this will be this equation. You can check also, like 5 pi by 2, if you will put here, you will get pi by 2. If you put 3 pi, you get 0. So finally, what we observe, that this line, which is this red line, which you are seeing here, is actually minus x plus 3 pi, and x is equal to 10. So these are all graphs, okay, and uh, they are not quite simple questions, but you have to know every angle of the graph. So if I finally want to know sine inverse sine 10, if I want to know that what is sine inverse sine 10, which is actually sine inverse sine 10, it is in the question. So this is x is equal to sine inverse sine 10. So this will be on the line minus x plus 3 pi, and x is 10. So minus 10 plus 3 pi. So this is the first thing which we have to write. This is minus 10 plus 3 pi. Next is y. Y is equal to cos inverse cos 10. Now similarly, you have to focus on the graph of cos inverse cos x. So just as we found it till here, now try in this one how we get cos inverse cos 10. Let's write all of this. This transformation of graphs is very important, because based on that you will get to know what are the equations of the lines. If it is shifting to the right, you subtract that much value. If it will shift to the left, you will add that much value. So if you see 10 in cos inverse cos x, so 10 is again greater than 3 pi and less than 4 pi. So 10 may be somewhere here. And if you see this line, so this line would be the equation. Now, what is this line? Can anyone tell? So if you observe that this line is y equal to x, right? This is the identity function here. And this is y is equal to minus x. Now, if we talk about this line, so this line will be y is equal to minus x plus 2 pi. Because what we are doing, we are subtracting 2 pi from x. So when the bracket will open, it will become minus x plus 2 pi. And then we have this here, y equal to x minus 2 pi. 2 pi distance, it is shifted to the right. Then this will come. So it will be y equal to minus x plus 4 pi. So this line which we are interested in is actually minus x plus 4 pi. So if we write the value of cos inverse cos 10, so that value will be minus 10 plus 4 pi. This is the value of y. Now what we have to find out is y minus x is equal to. So if you want to find y minus x, this is x and this is y. So we will get pi as our answer. So it will be option D, right? So let us come to another question. And for another question, we need to know two formula. So I will tell you both of those formula. One set of formula is that sine inverse of x is equal to cosec inverse of 1 by x, where x is less than 1, greater than minus 1, except 0. X is not 0. X is between 1 and minus 1 except 0, because in that case, cosec inverse will not be defined. Similarly, we have cos inverse of x. Cos inverse of x is actually sec inverse of 1 by x. That is x again between 1 and minus 1. And x is not equal to 0. Then we have tan inverse of x is equal to cot inverse of 1 by x. This is when x is positive. And if x is negative, then we have minus pi plus cot inverse of 1 by x. So these properties we need to know. And one more formula we need to know. First, write these properties. These are important properties. That tan inverse x minus tan inverse y is equal to tan inverse x minus y by 1 plus xy, where x and y are positive and xy is less than 1. Oh, sorry, I'm giving you the formula. Yeah, that is fine. Xy is less than minus 1 here it is. First, write them down. So now let us see a question. So we have to find the value of cot sigma n equal to 1 to 19, cot inverse 1 plus sigma p is equal to 1 to n 2p is equal to, and you have to find the answer. Options also let me give you. 21 by 19, and then 19 by 21, and then 22 by 23, and then 23 by 22. And one more formula you need to know, that is not from inverse trigonometry, like, and it is a very important formula of sequence and series, that if we have the sum of first n natural numbers, 1, 2, 3 till n, so it is n into n plus 1 by 2. This will also be used here. So I hope you have tried. So let us discuss it now. So obviously there are many concepts which are being applied in this question. So if you first of all start from this function, take it outside. 1 plus sigma 2p equal to 1 to n. So it will help in making a complicated question relatively easier. Because if you keep on taking the whole expression, it will make you confused. So let us take this one out. So this is 1 plus 2 outside constant p equal to 1 to n. So 1 plus 2, and this is 1 plus 2 plus 3 till n because it is sigma. It is 1 plus 2. 1 till n is n into n plus 1 by 2, as we discussed just now. 2 will cancel. So it is 1 plus n into n plus 1. Fine. So till here we have done. Now let us take this one out. So it is cot inverse of whatever we have solved here. That is 1 plus n into n plus 1. So now we can do one thing. We can write it as tan inverse of, since we know that cot inverse x is tan inverse 1 by x, if x is positive, we can write it as 1 by 1 plus n into n plus 1. So this is the second function, which is bigger than the initial smaller function. Now this can be written as tan inverse of n plus 1 minus n by 1 plus n into n plus 1. We can write it like this, of course, because n plus 1 minus n will become 1. And then if we see the formula here, this formula tan inverse x minus tan inverse y is tan inverse x minus y by 1 plus xy. So xy is greater than minus 1. This just a small changes here. This is greater than minus 1. So this is tan inverse x minus tan inverse y equal to tan inverse of x minus y by 1 plus xy. So in that situation, we write it as tan inverse of n plus 1 minus tan inverse of n. So this formula can be applied here. So first write till here. Then we have to do one last step where we will take the final all of this. Okay. So I hope you have written. Now let us take this cot of n equal to 1 to 19 sigma. And it is tan inverse of n plus 1 minus tan inverse of n. So this is what we have written. So if you observe this, this is like if you take n equal to 1, So it will be tan inverse 2 minus tan inverse 1. Then we have tan inverse 3 minus tan inverse 2. And like this, we keep on going till tan inverse of 20 minus tan inverse of 19. And it is cot of all of this, like this. So you write it here. Now, if you add them, tan inverse 2, tan inverse 3, so on, they will get cancelled. And cot of tan inverse of 20 minus tan inverse of 1 you will get. Now again, tan inverse of 20 minus tan inverse of 1, if you want to find out, you can apply the formula which we have done just here again. Now in the reverse order. Here we applied it like this. Here we will apply in reverse order. So tan inverse of 20 minus 1, that will be 19. By 1 plus 20 into 1, that will be 21, right? So from this to this, we will change it like this. Now tan inverse of 19 by 21 is cot of, sorry, it is cot here, and tan inverse is inside. So it will be cot inverse of, it will be cot inverse of 21 by 19. Now they will get cancelled and you will get answer 21 by 19, final answer. So this is option A, right? So let us come to the next question, which we can discuss. Now there is a question on inequality. So for this question, you need to know the graph of cot inverse of x. So inverse graph is not so difficult. Like if we have the graph of sine x, this is the graph of sine x. So it is pi by 2, it is minus pi by 2, it is 1, it is minus 1, it is 0. Now if you want to plot the graph of sine inverse of x, so it would be like this. So this is pi by 2, this will be 1, this will be minus pi by 2, it will be minus 1, and this is sine inverse of x. So this is the graph of sine inverse of x. Similarly, if you want to find the plot graph of cot inverse of x, we know that the cot x graph is something like this. This is the cot x graph. This is 0, this is pi, this is pi by 2. And if you want to find the cot inverse x graph, it would be something like this. So this is the cot inverse x graph. This is pi here. This is pi by 2. So based on these graphs, if we try to solve a question, it says there is an inequality which is cot inverse of x whole square minus 7 cot inverse of x plus 10 greater than 0, then x will lie in which interval? Okay, what is the solution set of this inequality? So just give it a try. I'll be back in 2 minutes. Just give it a try. Okay, so uh, you have noted it down, I hope. Now, first of all, what you have to observe here, that let us take cot inverse x as a variable t. Okay, instead of taking cot inverse x, let us take it as t. So this will become t square minus 70 plus 10 greater than 0. Our first task is to solve this algebraic inequality. So this will be middle term splitting minus 2t minus 5t plus 10 greater than 0. So this will be t into t minus 2 minus 5 into t minus 2 is greater than 0. So we have t minus 2 into t minus 5 is greater than 0. Now, if we see the algebraic scheme, it is 2, it is 5, it is positive, it is negative, it is positive. So if you want to find positive, so because it is greater than 0, no? So you find the t is either less than 2 or t is greater than 5. So what is t now? T is cot inverse x. So cot inverse x is less than 2 or cot inverse x is greater than 5. So we reached till here. Now after coming to this point, you have to see the interval of x. So just write till here. So now the graph of cot inverse x, that is important. After you have come to this result, now say this graph of cot inverse x, which we discussed a while ago. So if you see this graph of cot inverse x, this is a graph which is like this. And this is having this line, which is an asymptote. We call such line as an asymptote, which intersects is at infinity. So tangent at infinity. So it is pi. And this is x-axis. So, and this point is pi by 2. So cot inverse x lies between 0 to pi. It is neither equal to pi or greater than pi, nor equal to 0 or less than 0. It is in between 0 and pi. Now, if it is said that cot inverse x is greater than less than 2, so 2 pi by 2 is approximately 1.57, that is 3.14 by 2. And pi is 3.14 approximately. So 2 will be a value which will be somewhere here. So this is 2. And if we see the point where it is becoming 2, so this point is cot of 2, where cot inverse x become cot inverse cot of 2, that will be equal to 2. So cot inverse x will become 2 if x is equal to cot 2. So this is the point. And then we have the value less than 2. So this branch, the branch I'm highlighting here, this branch is actually less than 2. And another solution was cot inverse x is greater than 5. But that solution will not give you any region. Why that solution will not give you any region? Because 5 is greater than 3.14. And no part of the graph is greater than 5. The part of the graph is between 0 to pi, 0 to 3.14. So less than 2, of course, it will come, but greater than 5, it can't come. So less than 2, it is coming from cot 2 to infinity. So we will say the answer would be x belonging to cot 2 to infinity. Just write it down. Okay, so let us come to the next question. It is based on principal value. So the question says, considering only the principal values of inverse functions, the set A is equal to x greater than equal to 0 such that tan inverse 2x plus tan inverse 3x is equal to pi by 4 contains two elements. These are the options. Second option is contains more than two elements. Third is a singleton. Singleton means contains only one element. Our fourth is an empty set. That means it has no solution. So principal values we all know now, they're of different trigonometric functions. Like if it is sine inverse, so it is x belonging to minus pi by 2 to pi by 2. Then if we have cos inverse x, so sorry, not x belonging to, sine inverse x belonging to. Similarly, cos inverse x, so cos inverse x belonging to 0 to pi. If it is tan inverse x, so it is tan inverse x 0 to pi by 2 open interval, minus pi by 2 to pi by 2 open interval. It is minus pi by 2 to pi by 2 open interval. Then if it is cosec inverse x, so cosec inverse x, it is minus pi by 2 to pi by 2 except 0 because there it is not defined. Sec inverse x, it is 0 to pi except pi by 2. And cot inverse x, it is 0 to pi open interval. So these are the principal values of 6 trigonometric functions. So just keep that in mind. That is the basic basically that I have written here, but it is supposed that you know it. Here it is. Okay. So just try it based on this. And the identity which is very important here is these are the principal values. I'm giving you the time to write that question also. Just 1 minute. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. If xy are greater than 0, xy greater than 0, and xy is less than 1. So this is a formula, and there is one more formula which says that if xy are positive and xy is greater than 1, then it will be pi plus tan inverse of x plus y by 1 minus xy. So now you can write the question. I hope you have written this. Now you can also write this formula, which I've written here. So if you see this one, tan inverse 2x plus tan inverse 3x is equal to pi by 4. So you can write it as tan inverse 2x plus 3x by 1 minus 3 into 2, 6, x into x is x square is equal to pi by 4 if 2x and 3x are positive. So x is given as positive, right? X is given here as positive. So obviously 2x and 3x are positive. What else is that this condition says that xy is less than 1. So 6x square is less than 1. So either we get this, or we can say that it is pi plus tan inverse 2x plus 3x by 1 minus 6x square is equal to pi by 4. And here 6x square is greater than 1 because xy is greater than 1 in another case. So these two cases we have with us. Now, after writing this, you can say this is tan inverse of 5x by 1 minus 6x square, which is equal to pi by 4. And x square is less than 1 by 6. Or we have, if we solve this, tan inverse of 5x by 1 minus 6x square is equal to pi by 4 minus pi will be minus 3 pi by 4. And x square is greater than 1 by 6. Fine. So first write till here. So you have written till here, I hope.
Yeah, 1 minute.
Okay, okay. written.
Yes, sir.
Okay. So now if we write it as these are two cases. So in this case, tan inverse of this is pi by 4, which means that 5x by 1 minus 6x square is equal to 1 because tan pi by 4 is 1. And here x will be less than 1 by root 6 and greater than 0. Negative it cannot be because it is already given in the question that x is a positive value. Okay, if you see the question, here we have x is greater than equal to 0. So it is between 0 and 1 by root 6. So we write it as 5x is equal to 1 minus 6x square. And then this will be 6x square plus 5x minus 1 is equal to 0. So this will become 6x square plus 6x minus x minus 1 equal to 0. Middle term is splitting we are doing here. So it will become 6x minus 1 into x plus 1 is equal to 0. And it will give you x is equal to 1 by 6 and minus 1. So minus 1 we can't take, x is not a negative value. So we can take 1 by 6 because 1 by 6 is of course less than 1 by root 6. Okay. Yeah. So x is equal to 1 by 6. This is one solution from here. This is an answer. Here if we proceed, then 5x by 1 minus 6x square. Tan inverse of this is minus 3 pi by 4 is not possible because the principal value of tan inverse, as we just saw here, that tan inverse always lies between minus pi by 2 to pi by 2. Here we saw this, tan inverse lies between minus pi by 2 to pi by 2. So tan inverse of this cannot be equal to minus 3 pi by 4. So this is equal to minus 3 pi by 4. Not possible, as principal value of tan inverse is minus pi by 2 to pi by 2. So there is only one answer, that is x equal to 1 by 6, which we got here. This is not possible. So we will say that it has only one solution. So it is a singleton set. And write it down. Let us come to one more question. This would be the last question of the day. So if
1 minute, can I?
yeah, I'm scrolling up.
Certain.
Okay. So if alpha is equal to cos inverse of 3 by 5 and beta is equal to tan inverse of 1 by 3, where alpha beta lies between 0 to pi by 2, then alpha minus beta is equal to, options are given, but I'm giving you the answer. Just try to prove this. Sine inverse 9 upon 5 root 10. So this can be approached in many ways, like you can find sine alpha minus beta, or you can find cos alpha minus beta, or tan alpha minus beta. So if let me try tan alpha minus beta here. So tan alpha minus beta is tan alpha minus tan beta by 1 plus tan alpha into tan beta. So if you observe here, from here, we can say that tan beta is equal to 1 by 3. And if you observe here, so you can say that cos alpha is equal to 3 by 5. Now, cos alpha is equal to 3 by 5 again can tell you that what is tan alpha. Can you tell what will be tan alpha? It is like base by hypotenuse, no? And for tan, we need perpendicular by base. So base is 3 and hypotenuse is 5. So what will be perpendicular? Root over 25 minus 9, root over 16, that is 4. This is this triangle. Right angle triangle, which is having, okay, someone has given the answer, I think, 4 by 3. Yeah, correctly. So if this is alpha, so this is 3, this is 5, and this is 4. So tan alpha is 4 by 3, and tan beta is 1 by 3. By 1 plus 4 by 3 into 1 by 3, it will be. So this is what we will get from here. And if we simplify this, what we get? Tan alpha minus beta will become will be 9 by 13, right? It would become 9 by 13. Okay, if you simplify this, no? Numerator will become 1, denominator will become 13 by 9. So the reciprocal will be 9 by 13. Now this is tan alpha minus beta. Now if you want to find sine alpha minus beta, so again, this is perpendicular is 9, so you can take 9 here. And hypotenuse will be root over 9 square plus 13 square. So this will become 169 and this will become 81. So 169 and 81 will become 250. So this will be 9 by root over 250. Now 250 can be written as 5 root 10. 25 outside when you will take, it will become 5 root 10. So thus alpha minus beta can be written as sine inverse 9 by 5 root. This will be the answer. So keep trying the questions which will be given you in the assignment and apply different formulas. Basically, we have done formula, property, graphs, these things. So these you need to apply, and the definition also, that is the principal value and all.